Hey guys, this is Alan with Bothell STEM Coach, and today we're continuing on with AP Physics 1 problems. Here the focus is going to be some of these free response questions having some aspects of energy in them. So I encourage you to pause the video, read through the question, give it a shot, see how you struggle with it or if you're able to figure it out. Then come back and watch the video and see how you did. So here I have a pendulum consists of a bob of mass 1.8 kilograms attached to a string a length of 2.3 meters. The pendulum is held at an angle of 30 degrees from the vertical by a light horizontal string attached to a wall as shown above. On the figure below, draw a free body diagram showing and labeling the forces on the bob in the position shown above. Okay, well I always have gravity going downward, right? Force of gravity. I have a tension from this string here, we'll call it T1, that's holding it here. And then I got a tension here, T2, from this rope, pulling it in this direction. And that's it. Those are the only things touching the thing. Gravity and those two pieces of rope. So calculate the tension in the horizontal string. So that's T1. Okay. In general, to calculate the total tensions, I gotta do net force equations. But this is in two dimensions, so I got to do two-dimensional force equations. The only thing that has both x and y is T2, and this angle is 30 degrees, by the way. So in the x direction, I have, because I'm static, right? Like nothing's moving, so nothing's accelerating. The forces all have to be equal to each other. So T1. This horizontal force would have to equal this horizontal force because those are the only horizontal forces. They have to add up to 0 if there's no net acceleration. That's equal to T2 sine theta. And in the y direction, I have Fg has to equal T2 cosine theta. Right? T2 is this. The cosine theta gives me this side here, T2 cosine theta. Okay, so this I can solve for T2, and once I have T2, I can solve for T1. So T2 is equal to Fg over cosine theta, which is equal to mg over cosine theta. Then I'm going to plug it into here. So T1 is equal to, what's T2 equal to? It's equal to mg over cosine theta, sine theta. So m is 1.8 kilograms. 9.8 meters per second squared, divided by cosine 30 degrees times sine 30 degrees. Okay. 1.8, 9 times 8. Sine of 30 is 1/2. Cosine 30 is, so this is 1/2 divided by root 3. So 1 divided by root 3. You could do the trig functions in your calculator. I was just trying to speed it up a little. 10.18 newtons. Okay, that's what T1 is. That's what they wanted. The tension in the horizontal string. This one here. The horizontal string is now cut close to the bob. So we're going to cut here, and the pendulum swings down. Calculate the speed of the bob at the lowest position. This is a tricky question. Basically, it has no kinetic energy right when I cut it, and it has all this potential energy. And all this potential energy gets converted into kinetic energy as it falls. That's kind of how a pendulum or a spring or oscillation works. It's a conversion between potential energy and kinetic energy. This is the highest point. This would be the potential energy. Now, we have to figure out what this height is. And so you have to use, this is more of a trigonometry question at this point, because they didn't really tell you what this height was. They just told you this string was 2.3, and they tell you, and you can infer, as it swings down, this length is 2.3. But really what I need to know is the difference. So if I think of this 2.3, and I think of this going horizontal, I can make a right triangle, right? And if this is 2.3, I can figure out what this side is, because this side right here, like, I'm going to do it in red. This side just right here is 2.3 times cosine of 30 degrees, right? Because cosine of 30 degrees would be the length of this part here to this point divided by the hypotenuse, adjacent over hypotenuse. So 23 cosine 30 degrees. Cosine is root 3 over 2. So it's 23 times root 3 over 2. It's equal to 19.92 meters. So if this part is 19.92 meters, then this difference here has to be 23 minus that, minus this part here, right? Because if this distance right above here is, this distance here is 19.92, but I know this whole distance here is 23 because that's the length of the rope, then my height here is equal to 23 minus 19.92 meters. I get 3.08 meters. Okay, so that's my height. And now I can use my energy conservation. The potential energy has to get all converted into kinetic energy at the bottom. Masses cancel. Multiply by 2, so 2gh equals v squared. And so v is equal to the square root of 2gh. Square root of 2 times 9.8 times 3.08. I got 7.77 meters per second. Okay, so that was part C. So I hope you found that helpful. I'll see you guys in the next video. Thanks for watching the video, guys. Please leave a comment, like, or subscribe below to catch up more of the content. And see any links below. I offer free homework help on Twitch and Discord. See you guys in the next video.